You go ahead.
There were no other general psychological problems or pseudo-psychological problems that perhaps arose until when? Until people started getting PCs in their office?
Well, there were there were
As soon as you had the general sort of eco stuff, you began to have complaints about display terminals. And first there was the X-rays.
Look, we have gotten in an era
It wasn't
in
the
which people
X-rays, it
worry
was
about
posture.
everything.
people even used to complain about the thing responding too quickly. And people were just looking for excuses.
Responding too quickly. I hadn't heard that one.
Well,
I remember is it responding too slowly.
The minute you used it for any practical reason for any length of time, of course, that's what you were concerned about.
And boy, and the story about microwave too.
Well, microwave's another growing piece of hysteria.
Yeah.
No, it's a declining piece of hysteria.
And then
That's what circles are in.
I was worried
In
once.
Newton,
I was
we had
testing
people objected to a TV
and I wanted
repeater.
to see where it was spark. It was high power.
Blocked it.
It was sparking, and I was radiating.
There are
It went in front of the horn. And
Just because of the microwave power.
Just without
did
thinking.
something like
I felt
It's
my
really
face getting a
ridiculous.
little hot, so I quit immediately.
Yeah.
There are a few other questions we'd like to
We're back on
explore.
camera.
Yeah, we're back. And I'm sure you have a few points you'd like to raise that we haven't gotten to, but one of them that I'd like to raise is the reactions of people who were particularly security conscious to time sharing. Its introduction into the Defense Department, into places like NSA, into Eastern Europe and the Soviet Union. What do you know? What can you say about the problems that arose, the issues that were raised in places of that sort?
Well, let's see. We had some members of NSA at our summer study, people who were knowledgeable about computer systems, and was my recollection. And it was clear that they couldn't talk much about their environment, but it became clear fairly rapidly they had more computers than most of us had ever seen in one place. And because the scale of what they were worried about was large. And they also were already to the point where people were bothered by their inability to interact with computers, so they were quite interested in the consequences of time sharing. But but their primary concern was in the same utilitarian reasons that we wanted time sharing. The whole issue of securities over communication lines and security among users within the system, I'm sure to the more thoughtful ones was conscious, but it didn't block anyone from considering time sharing. And we certainly didn't put it at top priority in our own evolution in Project Mac. I think it was just a kind of a consequence of trying to think through a utility that you would have reasonable protection so users wouldn't get in each other's way and wouldn't have to trust one another unnecessarily. It didn't really begin to flourish in a serious way about kind of the espionage type security concerns until in the early 70s, it was my recollection. I'm not quite sure the precise date. And when the Air Force got interested in the question of whether you could have hardened time-sharing systems down in the Pentagon, and people like Roger Shell, who was a doctoral student under Salzer, and this is after he got his doctorate thesis, or did his doctorate, began to initiate projects to challenge how secure various systems were and whether or not it was possible to make a time-sharing system be break resistant. So there was really a second layer or second order effect after these systems were working. And to some extent people were more anxious to convince themselves that a time-sharing system was necessary or useful and so forth. Having found out so, then people began to worry about it. IBM, in fact, because they had paid no attention whatsoever to security in their initial design. Again, the model, I think, was that of a major corporation using their computers, and the corporation, of course, had no secrets to itself in a simplistic view, and so they didn't need any security. And as we may have mentioned yesterday, the initial 360 didn't even have read protect in the memory, and as a result, any user running a job could read from any other segment of memory, including one that wasn't allocated to him, and in fact could even read disk files if he knew where to read, so that they just didn't worry about it. They ultimately, again in the early 70s, partly in response to these kind of pressures that the Air Force was putting on vendors to have secure systems, they in turn tried to retrofit security onto the 360 systems. And it was, the trouble, of course, is that in doing so, the system became much less efficient, and the ordinary user wouldn't bother with it. And it's never been, Multics, I think, led the list of being most resistant, but even it was not perfect in the sense that there were always a bug hanging around and you couldn't prove you'd closed all the doors. But it was more amenable to repair. And so it's been a better choice for security purposes. But the weakest link in all those systems, Multics included, has been the way the system's been operated. And the procedures of operation normally have been flawed enough so that if you really wanted to crack a system, it's much simpler to go at it by very crude techniques like putting a phone tap on a telephone line or something like that, and just putting a little ordinary tape recorder on it, and you'll catch all the signals and you can analyze them at will later if you wish. So the issue is still an ongoing battle, but I don't think it seriously delayed nor it was a major design issue in the early time-sharing systems beyond the kind of normal ways of organizing well, perhaps I'm misrepresenting slightly. We did have an argument inside of the Multics development team. The Bell Labs people argued that in their environment, everybody behaved as a gentleman and nobody had to lock their office. And that, and also there was a group, the AI Lab group inside of Project Mac also had that similar attitude.
Well, they had a slightly worse attitude, which was that no one else should lock their office either.
Right.
They felt very strongly about defending that. And
the AI Lab people felt it was a right to read anything that was readable. The Bell Labs people argued that they didn't read anybody else's mail, and that if anyone was ever caught doing that, they would fire them, make them leave the club. We took the attitude that people were more fallible than that, and we needed to put in the checks and balances so that the ordinary person could choose which way he wanted it. So in that sense, we did take a fairly firm stand that some security should and access. Well, we called it access control because privacy, perhaps, where you would control and limit the rights of people to circulate information. That was, but yeah.
There are some very subtle things there. I worry, of course, a lot about the privacy issue. That is, security in a non-military environment. And one of the things that is very striking is that most people, I would almost say all people, do not translate the accepted conventions and rules of behavior and morality that is developing in conjunction with paper files to the computer situation. They just don't. People that would never go and open the file in somebody else's office doesn't feel at all compelled not to look at the computer file. So this complicates very much the whole situation. Now, there are extreme cases, as Ed was saying about some of the AI people that object to anybody's locking his office, you see. But look, the locking your office and a lot of similar things really is not a security, really, because anybody who wants to unlock those offices can do so. It really is a signal that says this is private. And if you are a decent person, you don't get in. Because if you want to, you can get in, right? But there is not, you see, if you have a computer system that doesn't have the equivalence of lock, even if somebody could go around, that signal doesn't exist. And then if there is absolutely no protection, it is assumed that that's all right. And there have been plenty of problems of all sorts resulting from that fact. And unfortunately, the number of systems that really say no, you don't get it here, in a strong way to indicate this is bad if you try to break through, practically don't exist, you see. And that has led to all sorts of problems. There is any undergraduate can break into the DEC 20 system and do all sorts of things. We had problems. Like for instance, you know, I was one day I had a new secretary, who fortunately was not a young girl. She was a more mature person, and I was just showing her the system. Well, so an undergrad had put in the message of the day a pornographic picture.
Picture?
Yeah, drawing. Yeah. All right, she was not embarrassed. She was, but you know, that sort of thing, this is just one little example. But all sorts of things have happened.
The Cookie Monster is another. The Cookie Monsters. I don't know if you'd run into the Cookie Monsters.
No.
Tell the Cookie Monster story. Let's get on the record.
Well, this showed up initially on, I think, one of the time-sharing systems. I first saw it on ITS. You'd be typing along, just doing your work, and in the middle, suddenly your terminal would type out, "I want a cookie." And you'd think, now, how did that get there? And you wondered, did it get in your file or something that maybe you're editing? It wasn't there, and so you just ignore it. You shrug your shoulders and start typing, and nothing would happen. Maybe 10 minutes later, it would type, "I want a cookie."
Yeah.
Then later, it would say, "I want a cookie now." And then, you know, it would start every minute. "I want a cookie, 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 cookie," it would type. And it would get madder and madder. And it turned out if you ever typed cookie, it would go away and not stop bothering you. That's all you had to do is type cookie. Well, certain people would get mad and they would go and find this program and eliminate it. Or the people who put it there would get more clever. And they would make it appear, type cookie, and then disappear. And so this got to be a great battle. And I know of this one case where the one guy who was most anxious to get rid of all Cookie Monsters had this appear on his terminal, you know, and he was really mad, and he worked like a demon. He could not find it. And what someone had done is taken his terminal and built in a little microcomputer, right? Put it in his terminal. It wasn't in the machine he was using. And it lay in wait there for, you know, days, and then suddenly would type cookie on his screen. And
Yeah, there are pranks.
Lots of pranks.
But then there is the thing that go beyond being a prank.
Yeah. Right.
And there are all sorts of things. For instance, certainly there have been enough, as I was mentioning yesterday, things in the news about computer theft and all sorts of things that clearly indicate that there must be a heck of a lot more going on. And yeah.
I know one day on my desk at MIT, there appeared from someone, you know, a printout. And it was a comment written by hand, "Thought you might be interested in this." And what this was, it was a chapter from some book that some person at Xerox was writing, obviously taken off of their machine. And someone did enough browsing through enough files in some machine in California to discover this thing and got it out and printed it, and you know.
The fact is that the present computer systems are commercially available, with some notable exception like Morse. They just really have don't even pretend to have a protection. You don't have to tap a line. You don't have to really.
Well, they're firm enough so that they work reliably against, as long as people aren't being malicious or reasonably well. Where they falter is when people are deliberately intent on trying to go through the barriers. And yeah, they're not hard enough. But, this is kind of a running warfare. It's no different than burglary in buildings and things, where it's quite obvious which direction
But
to push.
part of it is since the thing that the people are after is just to satisfy their curiosity, and it's more of a sport. The population of people who indulge in it is different, than for burglary.
Maybe in some circles.
Well, I mean,
it's a sport.
at MIT, maybe that.
There are
But
other
in
places.
business, it is not.
That's true.
I mean, I can tell you stories about CTSS was not very secure. It had bugs, despite of all the efforts. And people were taking advantage for various purposes. There were the pranks. For instance, the person that one morning I started working instead of the Mac system was the hack system. Well, that's a little innocuous prank. It got to be kind of irritated when I tried to log out, and the logout command had been disconnected, so I could log out. But it was still in the nature of the prank. And then there were people that were essentially stealing computer time. Computer time had to be allocated, and some people, mostly in the Sloan School, were setting the counter to 0. Well, I mean, if you look at that, since this was a resource, a community resource that had to be divided somewhat fairly, that meant really they were stealing the commodity from somebody else. But that translation was not made. And there were all sorts of things in between. Then there were things that were just downright nasty. This is in an academic institution. And when you get into business, at one point I had a hypothesis that there's a lot in the newspaper about, particularly relative to, in the stock market, essentially the stock broker losing piles of money. Because of stocks that were missing or whatever it is, and I had a hypothesis that their computer system was so breakable that there was organized and disorganized crime getting in. And I had a student who happened to work in a broker's office during the summer, tried to make a study, see whether this was, what was going on. Well, he didn't get anywhere because the computer system was such a mess that this issue of access control was way below noise. But that's another story.
How far did these considerations restrict the spread of time sharing in business, in national security organizations, and also in other countries such as the Soviet Union?
Well, for instance, Lawrence Livermore Laboratory wanted to use time sharing, and they needed absolute security, and they had a very simple way. I mean, they put a wall around all the terminals and everything.
Right.
And the whole time sharing system would be in this walled-in room, and it was secure. I was there once when they had this enormous crisis because a disk file broke, and the guy from Digital came down, and they elaborately let him in, and he replaced the disk and took the old one out, you see.
Ooh, yeah.
And when they realized what he'd done,
That's
they had a
no-no.
total fit, and they had to run and get him and, grab the thing back.
Right.
But the people who wanted to use it saw no problem in just putting a wall around it and using it. And in the Soviet Union, what I can tell you is that they wanted very much to have time sharing, and considerations of things like security were only maybe hypothetical considerations. In other words, their inability to develop this and put it to use was more their sort of lack of basic capability in the field, and not anything to do with intent. Yeah. I think there's a difference there between time sharing, say, in office copiers. There's a dearth of Xerox-like copiers there because they're viewed as a dangerous thing. But time sharing, really, they would have liked to have much more of than they had.
There's another side of the coin to the security thing too, which the systems that didn't emphasize security and allowed various kind of freewheeling browsing through all the files of all the users have had a phenomena which is an asset from the point of view of the sociology of use. Systems like Multics, which had all the potential, were able to seal off every user and kind of isolate him. We only allowed 1 or 2 breaches of the complete security picture. One of the breaches was being able to ask who else was logged into the system. But we didn't even allow information like what their home address was, what their telephone number was. We didn't allow even knowing whether they were active in the last few moments or not, or whether they'd received any mail recently. Those issues were filtered off. Other systems that allow these, which you can view as security breaches, because they give you a measure of activity and interest, and even some insight as to who the person is, so you can contact them with a phone or mail. They've had the phenomena of having a much stronger sense of community, because people get acquainted over the system. They send mail to each other, which you can do in Multics, but you can't send mail to someone you don't know. And that's the problem, that Multics in its current states is demonstrated. And so a lot of effort is now going into most time-sharing systems in trying to develop techniques for encouraging community sense. One of the most obvious that most time-sharing systems are now developing in various forms is kind of electronic mailbox, or electronic bulletin boards, I guess would be a better characteristic, where a whole group of people can cluster around some particular interest and send messages to each other, and they can all read about all the messages from all persons. But too much security puts each individual in a straitjacket where he doesn't see the community, and it really is a loss.
I think there's one direction you're trying to push us or get answers to questions, and my own feeling is, aside from some very minor occurrences, questions of security really have very little inhibition on the growth or application of timeshare. There were some people who would say, gee, I wish this could be perfectly secure, but really, both in the government and in industry and so on, those people who wanted to use time-sharing used it, and those who didn't. Sure. And this was one of the smaller issues, I think.
Yeah, I think I agree with that. On the other hand, I am just concerned about the spreading not in academia, but in business and other areas, about time-sharing systems that have plenty of holes. At one point, I was on the Governor's Commission on Privacy in Massachusetts, and one of the issues was police systems. And they were totally, anybody could get in by tapping the line, by all sorts of ways, and they gave the impression that the information was protected, and it wasn't at all.
Yeah.
I would say that the primary thing is total lack of concern on the part of most people with those problems.
Yeah, but the concern ranges both at the control of access level and also at the control of the information. One of the problems of those police systems is that people don't take an adequate view of maintaining correctness of the data. And,
that's the other.
That has nothing to do with the equipment. It has to do with the way it's being utilized.
That's another thing, because we keep talking about privacy in the sense of people not having access. But the most serious problem is people being able to get in and change information. And in fact, banks are very worried about that. All you have to do is get Dick Mills to come here. I'll tell you, because he spent a lot of effort for Citibank in that respect, because a very large amount of money.
This is a good time to bring up something, we may be beating this further, but say Citibank, and did at any time AT&T or other communication utilities or when the banks were going to get into this, I know Citibank was always concerned, think of the problems that happens when you become a public utility. Was IBM worried at an early point about what happens if they get regulated because they're making computers which become utilities? Did any of that ever happen?
Almost everybody that was sensitive to that topic wanted us not to use the word utility because they didn't want any
That's
regulation.
There were some concern at some point, and let's say when GE made the decision to go in business, there was quite a bit of discussion about that. Let me see, who was somebody Manley, who's professor at the University of New Hampshire. Manley Irving, who was very interested in those issues. He was at the FCC for a while, and he's the one that started the inquiry in computer and communication way back. And defining, in this whole business, what are the components of the whole business and how they ought to be separated in a rational way, between manufacturing, operation, communication, and whatever. But I don't think, as far as I know, that the issue of what are the components of the whole information processing business, and how that business has to be structured to avoid problems, has been duly discussed.
I think it
know
has.
that you are very much interested in that, Ethiel, but I'm not aware that there's been a discussion as a whole. For instance, I am somewhat appalled by what happened in the television industry.
Well, I think it
because
has been
of lack
discussed.
of thinking that is allowing essentially the programmer and the broadcaster, in the sense of the technical aspect, to be one and the same entity, separate completely from the manufacturer. It created boundaries in the industry that have frozen things in concrete. Like, for instance, that thinking about moving away from a low definition TV, like we have in this country, to the high definition in Europe is practically impossible. So there are issues of that type that come up, and I'm not aware of that. Those issues have been really considered in detail by competent people.
There was, in the time-sharing context, there was occasionally almost hilarious concerns for security. Probably one of the more famous ones was an accident that occurred in the use of early CTSS after Project Mac got established, where one day, to everyone's dismay, in late afternoon, that was logged into the system, they discovered that instead of getting the message of the day, they were getting the list of all the passwords of all the members of the community, the 200 or 300 people that were authorized to use the computer. And this went on quite a while, and about 15 minutes, so that everyone that logged in that 15-minute period had a written record of all the passwords.
Until a system program crashed the system.
What had happened was one of these sequence of minor oversights where, because terminals on that particular system were associated with a particular directory, and we had to let the system programmers, two system programmers both work at the same time, we'd allowed put a shortcut in the system, which in fact was allowed one to breach the normal rule that only one terminal to a directory. And so two system programmers, unbeknownst to each other, were both working at the same time, and they were both using a common editor. And one had been working on the message of the day, the other had been working on the password file. And the editor was crude enough so that it put a temporary file out in the directory, which always had a unique name. And so the two invocations of the editor had gotten swapped on the use of which temporary file. And hence...
This didn't even happen on purpose.
It didn't happen on purpose, but it was... The consequence was devastating because the only sensible thing to do was to change all 300 passwords at once. And so that was done by Tom Van Vleck, as I recall, stayed up all night creating and typing out new passwords for everybody, and everyone that tried to log in the next day was, please see system administrator.
I'm wondering, did you yesterday cover, what went on in the very beginnings of this? Has that been something? Because it seems to me that it'd be perhaps more interesting to think about, I don't know, the earliest times when, I don't know whether you feel we've explored
Well, I suspect we did, but go ahead, because we didn't get your input on that, so why don't you say it?
John covered in the late 50s how he kind of gelled onto it a little bit. And how we were doing all the report writing at MIT stuff, sort of building up a head of steam.
Very valuable.
But maybe you have some insight too.
Well, no, I don't know that I have anything so much in particular, but just that, it was quite an adventurous time. There were lots of ideas around and a lot of technical problems. One I remember had to do with this thing, the interrupt, which is something that I got involved in.
One question came up yesterday, John asked it, was where does the originality of interrupts lie?
Okay, I can tell you a little bit about that. It's like many things in the computer field, the number of contributors to just an idea as simple as interrupt must be very large. What I remember is that on the IBM 704 there was a kind of interrupt called a trap. A trap. And there was a transfer that would trap. And what this meant is if you executed a particular instruction and there was a certain condition, then it would go somewhere else. That was a form of interrupt. And then a lot of the ideas that were, there was a French machine, think of it, that had a lot of good ideas in it, never got anywhere aside from that. About that same time period. And then the TX2 had a big interrupt scheme, and that it had a lot of different program counters, one for every device, and they had the idea that the main machine would handle the different devices by interrupting itself. What they did is they put a bit in every instruction, because the concept of all interrupts in that time was that when you had an interrupt, the new program that ran would use up the information in the processor, and so you would lose it. So it was important to not allow this to happen unless, this is sort of a little bit technical, but unless you didn't care about that information. And so there was a bit in every instruction in TX2 that if the bit was set, then you could have an interrupt, and you were supposed to have that bit set whenever you didn't care about what the data was in the processor. And when the PDP-1 came along, it was such a fast little computer that the idea that the processor could handle every aspect of what was going on in the machine seemed to be a good idea. And I modified the interrupt idea in the following way. It occurred to me to simply change the machine so that the interrupt could happen at any time. And all you had to do there is when an interrupt happened is to save the registers of the machine. And that was the sequence break system. And all these little stages, contributed. Today, almost all modern machines use at some level the concept that you save the state of the machine. But one brand new machine that I know of, which is microcoded, at the microcode level, it works like the TX2 in that it has to check to see if there's an interrupt pending, and it can only do that when it doesn't care what's in the register. So these ideas, which are important, seem to evolve. And I've noticed a fact about the development of time sharing, which is probably true about computers in general, about these technical ideas, which is that a lot of the very good ideas come from experimental systems that are a failure. And the reason they're a failure is that the chance that 10 great new ideas will all work is almost zero. Maybe 6 of them work, and if you have a machine with 4 important concepts that don't work well, the machine's a failure. So when you get a great creative burst of energy and you think of lots of ideas and the machine stirs up a lot of interest, you know that in its implementation it may not be very important, won't be a commercial success, but the ideas propagate and they evolve from one system to the next. That certainly happened in the whole time sharing effort.
But can I make a comment on that? That whole technology transfer, though, the thing that has, I think in the early days, people used to think that the equipment would be evolved by, in the same design would keep evolving. And by and large, I think almost all of the examples are that every step forward has been by a total re-engineering. Very few people, so the technology transfer is through the minds of the designers rather than through imitation of the precise imitation of the design.
That's right. But what normally happens when the design first comes out, it has to evolve some to get the bugs out in some sense, the conceptual bugs, and maybe a second version of it.
Right.
I mean, if you look at the 701, 704, 990, there's a whole sequence of evolution that got better and better, and then suddenly you have a whole break. You start off with System 360 and so on.
Well, certainly all of the time-sharing systems that I knew, they were first started in rather primitive form, and then they got refined and modified. So there was actually a sequence of versions of that system, but then they have to break off.
I used to because
well, I just wanted to say one more thing about in those earliest days. I don't know if you covered anything about like some of the most powerful motivations, the sort of tyranny of trying to use a batch system. But for instance, I remember when I was using a 704 and a 709 at Lincoln Laboratory, you would schedule yourself 15 minutes, and you would schedule it the next day, and you'd come there with a batch of cards, and often you would put the cards into the machine, and it would instantly, like the Fortran assembler would complain on the third card that you have a comma where you should have put a period. It would say error number 729 or something, which meant you have a comma, which would make you mad because that meant it knew that you should have had a period there. And you might have had more errors, and you didn't have a chance to find them out. And so people would frantically play with the switches or rush to the card punch to try and use their 15 minutes and fix that error and go on. Well, the masters of the computer would see that part of the time you weren't using the machine. They thought the whole object is to keep the machine running all the time. And so they made another rule that said if the machine stops, the run light goes on, and you can't get it going again in something like 15 seconds, then you're done. Didn't matter that you'd scheduled 15 minutes. You couldn't use the rest of your time. They'd bring another job up. So what I did was I made a short little program which went in at the head of every deck of cards. And what this program would do is, as soon as my program would halt for any reason, I just go to the switches and start it at this other location. And it pleasantly and busily flashed the lights. That was one important thing it did. But it also, if I would put a number in one switch, set the address switches and throw a sense switch down, would then in the lights put the contents of that register up for me, or I had it so later so it could dump a little bit of memory and stuff like that. And thus I was always able to use my whole allocation because I fooled the people into thinking this is what it was supposed to do, things like that. So there were efforts to try and get around because the people who ran computers couldn't understand what the problem is. The problem is to have the machine not be busy all the time, so that, Or another example is in the early days of time sharing,